everyone, and welcome here to Wix, to my home place. So my name is Ola, and I'm data scientist here for the past 3.5 years. And I would like to apologize because my voice is a bit trailing and it can disappear, but I have tea, so I will do some small walks. And today's talk will be dedicated to a journey to a project that had so many ups and downs that I didn't believe that we will manage to success. And it's really related to the previous talk, so thank you for the intro. And I hope that some of you will find something to relate to, or maybe you will learn something new. And so let's start. So first of all, the talk will be split into 4 parts. At the beginning, I'll say a few words about Wix and data science at Wix. What do we do here? I would like to explain also what is machine learning, because I believe there are people with different backgrounds who don't know how it works. Go through the life cycle of machine learning project, and then finally go into my journey of learning the beauty. So I believe you've heard about the Wix. Many of you know Wix as a website building platform, and yes, it's true, we are building web presence, but also there are so many more things that are related to it that we develop, and some of them will be revealed in this presentation. So more things about Wix. Overall, we support over 154 million users all over the world. And the things that I want to deliver to you, like one of the main slogans that actually push and drive our product and teams all across Wix is "It's that easy and start stunning." Because we want our customers to have very easy solutions and also for them to look very beautiful. And another thing that is very important for us to deliver business goals. So Wix is a highly data-driven company. And why I want to show this? Because this is something that drives data science team as well. And the data science team is a team of 50 people in Ukraine, Tel Aviv, and also in Canada. So data science team consists of 3 sub-teams. So we have data curation, who prepare our data and does data labeling. We have data scientists who develop models, and finally engineers who actually put it in production. And a few things that already delivered to our product, and you can see it online, is object cutout. So this solution provides for the users with the online store a possibility to upload products and very easily to remove the background. And then you can play with different colors and make it look more professional and more clean. Another thing is auto-enhance or auto-photoshop, which, of course, we take different quality photos. So we want to help users to make the website look much more better. So again, in very easy click, you can improve the quality of the images, the solution that was developed in data science team. Another thing is we are public companies, so we also need to track our financial advances. So we need to provide the prediction for the market, what would be our performance in the quarter or a year ahead. And just to explain how important this project is, like just 1% error is $5 million. So we really need to work on it very, very hard. And also we do a lot of text analysis. So this example is coming from our customer solution system, where we analyze how satisfied are our customers with the help that they got, and also for the agents who are helping the users, because we have over 160 million. So we need to provide very quick solutions, and we develop a model that helps finding the better articles in knowledge base to provide for the agents to resolve it faster and better quality. And of course, we have many, many more. And I just wanted to show what can you do with machine learning, what can we do at Wix, and then rolling back. So what is machine learning? What actually I'm talking about? And I really like this explanation. Maybe some people wouldn't agree. It's actually machine learning is a science to get computers to do something for you without explicitly programming it. OK, so what does it mean? Let's look at the regular algorithm. So we start with some kind of an input, some beginning. And then we want to apply logic to get to a certain result. That's usually how it works. It's rule-based. So what is different in machine learning? It's actually that we start with the start, and then we also give it the answer. What exactly? We're giving what we're supposed to get at the end, and then we throw it into the algorithm that produces the logic. So it's a bit reverse. We start from the beginning and the end, and then the logic appears. And then this logic you can apply in different places, as this logic that we applied before. And to make it easier, I will talk about dogs. And yes, so let's imagine that we have a problem. We have a huge gallery of photos, and we want to separate photos of dogs from something else that we have. So we have these images, but we don't really know which images is what. And how do we do it? So first of all, we need to label the data. We need to understand where do we have dogs, where we don't have. So we go all of the images and put the label yes or no. Great. After we prepare all the images, we throw it into machine learning algorithm that's supposed to create a logic that would generalize the idea of what actually makes a dog a dog. So this process is called training. So we are training the model until the error is very, very low, until it actually can separate those. Then we stop, then we save the model, and we can go to the next step, which is the prediction. So we have something, and let's just show image of a dog that it never seen before. Yes?
What's the threshold of the training? Like, what's the statistic in terms of how accurate it needs to be?
It depends. It depends on the cause. So I cannot tell you it depends on the demand. It also depends what is the evaluation matrix. If it's critical for you to be very, very accurate, or you actually can allow some kind of an error by just having bigger population being brought. It all depends on kind of projects that we are dealing with. So there is no rule of thumb. Okay, so, but what happens if you see the images now, the labels are reshuffled. So we're actually feeding into the algorithm something that is not good. So will it produce a good result or not? Maybe by chance, maybe by luck. But usually what we like to say that garbage goes in and garbage goes out. That's exactly how it works. So here I explain a bit like very simplified way of how the machine learning works. And then let's go to the machine learning processes, the life cycle. So how does usually the work of data scientists start? It all starts with problem definition. So we getting our stakeholders coming and saying, okay, we have this idea of the project, let's do it together. This is great. But we need to define it, okay, so what is the goal? How can machine learning help? What should we work on? So after we decided with the stakeholder, we're like, okay, I think we got it. Let's understand what kind of data we need. We talk about the data, we agree, and then we get it. So getting the data, it's exactly as the example before. We collected images in the gallery of like dogs and non-dogs. And then we also, in the get data part, we also need to get the label. Very often, label is actually coming with the answers. So if you want to see our financial result, how will it perform in the future, we can take the past data because we have the label. We have the numbers of how did it perform before. But for some of the tasks, as classifying dogs versus cats, we needed labels. So this part is getting data with the labels. Then it goes to the next part, cleaning the data, preparation, manipulation. When I was talking about working with the images, we cannot just throw PNG files into the computer and says like, okay, do some magic. We need to transform it. So there is a process of transformation data into understandable by the machine language, which are numbers. So text convert to numbers, images convert to numbers. Also in this process we have the so-called feature generation when we try to come up with, okay, so what additional things can help the model to become better? Like maybe cats and dogs, maybe we also know that the files that, all the files with the images that actually had suffix or prefix with dog or not dog. So this is something that also stays in this part of like generating data, preprocessing data, and creating the machine understandable code. After we have that, we are moving to the training. So I showed you the training before. We are training the model, trying to minimize the error. And after we kind of satisfied, how do we know that it's actually good or not? Because we like threw the trained data and it was learning on its own. Maybe it actually understands very well how to classify what's going on there, but it doesn't understand how to perform when we expose it to some other images. So on this get data part, what we do, we actually keep some chunk aside. So just imagine that we take 80% of images that have a label, we use it for training, and 20 that we have the answers for, we use for testing. So we test against it. After the model is trained, we test, we look at the performance, and we analyze it. And the next step, improve. There is always room for improvement. It never goes like this, flatly, without any bumps on the way. And the improvement part, it's important to understand that it can get to any of the previous stages. It can get all the way to problem definition. Maybe we understood that something is wrong and we need to change it. Of course, maybe we need to get more data. Maybe the labels are incorrect. So the improvement part is just cycling back all the time. And then when we finally happy with the model, when we agreed with the stakeholder that this is exactly what they want, we go to production. So we deploy it. And this is basically the whole life cycle of how the project, data science project look like. But I would like to ask you a question. Which parts do you think take the most? Takes the most time.
Getting data and cleaning the data.
Excellent. So when it comes to machine learning professionals, data scientists, we don't build super sophisticated algorithms and neural networks. Most of our job is there, on like cleaning the data, getting the label, and trying to crunch it to make something out of it. It's all the data work. So bear it in mind because it will be very relevant for the next step. Teaching machine beauty. So that's why you came here today. And at the beginning, I would like to give you some context. What will I be talking about?
Hey, I created this beautiful logo for my bike shop with Wix Logo Maker. Check it out. Go to wix.com logo maker. To start, I'll type my business name and my tagline, but make up your own. It's for my bike shop, and I want my logo to be dynamic and playful. Now this is smart. I can show the logo maker exactly what I want. I'll use my logo on my website, business cards, merch, everywhere. All right, Wix Logo Maker, show me what you got. Whoa, so many designs to choose from. I'm feeling this one, and I can customize it even more. I want my icon to be, well, iconic. And I'll change the colors. This looks great. I put my new logo on business cards, bags, and my new Wix site. It's not just my new logo, it's my new brand. Go to wix.com logo maker. Create your professional logo today.
So I got approached by the product managers from the Wix Logo Maker, and they said, let's do something together. And what did they tell me? How did they define the problem? Let's help users create more beautiful logos. Sounds fun, but what do you do with that? It doesn't have any kind of description, any type of direction. So we tried to crunch this sentence, understand what is the missing part. So the logo project existed already for a couple of months. We have 100,000 logos created by the user, but we actually are missing one very important part, beautiful. So what is beautiful logo? So we decided, okay, let's try and build the model that actually understands the beauty. At that point, it's like, let's try to do it. Why not? We are machine learning experts. We know everything. We can do everything. And it all starts with, so here we define the project. So it all starts with getting the data. And did we have inputs? Yes, of course, because we had hundreds of thousands logos that were ever created by our users. But do we have a label? Do we know which one of these logos are beautiful, which one are not? And of course, I want to give a disclaimer. Beauty is still subjective. No one takes subjectivity out of the logo. But let's just imagine that let's simplify it. Just try to pleasantly look at something that is, for most of the crowd, they would say, this is pretty. And no, we didn't have anything. So we knew that if we don't have anything, we need to go through the labeling process. We need to get the label. And during our defining of the labeling process, we usually answer three main questions. So the first one is what what kind of label do we want to collect? How it's going to be? It's going to be some kind of numeric label, it's going to be some verbal label, it's going to be binary, like yes or no. I don't know. Who will be doing the labeling job? Will it be domain expert, or we can just ask a common crowd to do it for us? And then where? If we are doing it in-house at Wix, or we actually outsource it. And when we started the project, we knew the answers. We were sure about the answers. So, okay, let's ask someone to rank it between 1 to 4. Why 1 to 4, not 1 to 5? Because we had clear idea that if we ask people to rank between 1 to 5, everyone will be falling into 3. Okay, so we decided, we know it for sure. Second of all, who will be doing it? We are talking about beauty, we are talking about design. There is no one better than designers who understands beauty. So let's ask designers to do it for us. And where do we do it? So Wix has the biggest design studio in Israel. Why do we need to ask someone else? Let's just go to our studio and ask them to do the job. So what we did, we collected a list of a couple of thousand logos, and we found 3 designers from the studio, and we asked them to rank each logo between 1 to 4. So actually, the same logo was ranked by 3 different people, because we wanted to remove the bias. And after a week and a half of work, I got the results. So actually, what do you see here? There is designer 1, designer 2, designer 3. And the distribution of their opinions, how many logos got 1, how many 2, how many 3, how many 4. So we looked at these results, we compared them, we matched. The variance was huge, and no, we cannot work with this data, it's not workable. Okay, we came back to the studio and said it doesn't work, and they gave us logical answer. We are talking about designers, and they are the people who create design, they have their taste, they follow the trends, so they are not really good probably for this job. Ask someone else, and we actually have the content designers who, they don't really create shapes and images. What they do, they select the content for the websites. So basically, when you go to the template, it's very, very pleasantly looking because these people are evaluating it, so it would be very pleasant to look by common crowd. And we exposed it. And after a week and a half of work, we got this one. Okay, fun. Maybe it's impossible to do that. And me and the head of data curation team, we were trying to understand why they disagree so much. Maybe it's really such a subjective task that it's impossible to tackle. And what we did, she was sitting behind me in front of her computer, and we were doing the same logos, 200 logos, and then after we compared results, and we mostly agreed. As I don't have any design background, she doesn't have anything. So we thought, we don't really need anyone who understands the designs. Let's just ask common crowd to do this job for us. So what we did, we brought 3 students and again exposed the job with very clear instructions. We really worked hard for a couple of days to define exactly what they're supposed to do. And we shared it with them, voila. So the first observations that I want you to make, I don't know how, but there is always an evil one to the crowd. There is always one person that doesn't like almost anything. And it's, again, 3 separate experiments. They never spoke to each other. It's just the data of what we got. And the second big thing is, it's a failure. Come on. It's really a failure. We didn't get any labels. And it was, to be honest, devastating. We spent so much time trying. We were sure that we know what we are doing. And we were working so hard on the instructions, on moving back and forth, on operations, because we need to manage students. And we failed at the end. So we tried to understand what went wrong. What was wrong with overall what we did. First of all, it's one of the feedbacks that we got is we're not sure that the way you ask questions is that logical. I'm used to 1 to 10, I'm used to 1 to 5. I don't understand how to rank it. It's very hard to connect your feelings and emotion about beauty to some number. Okay, nice feedback. And second of all, it took us so long. It was month of work and for nothing. So we had to tackle another problem of velocity. How can we do something faster? And I don't know if you ever heard about crowdsourcing services. So this is the place that data science team at Wix, we work with them quite often. you upload for them a labeling job, and then the job is being distributed all over the world, to India, to Philippines, and people doing labeling. And in this way, we can have, instead of asking 3 people to rank the same logo, we can ask 20 people to do the same. We could easily play with a tool. We can create like multiple different tests. Another benefit that we can have from the crowdsourcing services, that we can ban people if they are not doing the job the ways that we expected. So at the beginning, we would create a test set with what we consider to be beautiful and non-beautiful, and then if they fail to agree with us, we don't want them to continue. So that was amazing. But the main thing is that we actually could fail fast, because before our failures were very, very slow. And in this way, we can create multiple tests running in parallel, exposing to thousands of people all over the world, and we can get results within an hour. We don't need to wait anymore. And what we did, we started to create different kind of ways asking questions. So we would show a logo, and how would you rate this logo? They said, it's very hard to connect to numbers, let's try to connect to words. So we did this. Failed. So the next one, maybe let's simplify it. Is it beautiful or not? Make it binary. Failed. There were 10 other tests that I didn't want to show here. And we also did, how would you rate this design between 1 to 5? And probably you remember from the beginning, we said, let's disregard it because we are sure everyone will be falling in 3. And it's not true. It's actually something that we were wrong from the beginning. It didn't happen. It didn't happen, people had opinion. Of course, like here you have aggregated between 20 people, majority vote, so we don't have 1 and 5. But at least you understand this middle. It's easily separated. So this is great, and I said, okay, let's do it. And then the head of data creation team told me that she'd heard something about a different way of asking these type of questions. She thinks that the best way would be to ask which one you like more, the pairwise comparison. Because it's so much easier for, if you have 2 channels, to understand what are you more inclined to choose. So we did this test. And also another benefit of crowdsourcing services is that you can collect a lot of KPIs. So we define the feedback score. The feedback score is something that people, after working on the job, they tell how easy was the job, was it fair, did they enjoy it. So actually the feedback was very, very high comparing to the best of previous experiments, rank 1 to 5. The percentage of success, which means how many people managed to pass the test, was dramatically higher. It took less time, it was cheaper, so we knew we found gold. We knew that we have something, and we have something to work with. But there is another problem. So what do we have? We have this, okay, logo 1 better than logo 2, logo 3 better than 5. How can we actually translate it into something that can be used as a label for machine learning task? And when thinking about the whole approach of doing the comparison, it felt kind of like a game, right? The logo 1 plays with logo 2, one of them wins. And just driving this thought further and further, I got to the algorithm of ILU score. I don't know if you ever heard about it, but that's the algorithm that is being used in Czech chess tournament since 1960 to determine the people rank on the table, like tournament table. The game is very long. You cannot have everyone playing with each other. And to explain this in very, very simplistic way, I will go from beauty to violence, so excuse me. We have a boxing match. So we have guy in green and in blue. And so here you can see some stats, but to make it clearer to understand, the bars that you see on the side is their ranking, like how strong they are. And then we have a match. We have a match. As you remember, the guy on the left, he was like much higher rank, and it was quite obvious that he will win. So what happens when he wins? We actually add him some points, but very, very small amounts that have been taken from the person that he competes with. And why it's such a small bar? Because we expected it. There was no moment of surprise. So basically, we calculate at the beginning the probability of boxer 1 to win over boxer 2. And if it's very high, so it's going to be a very, very small adjustment. But what happens if the other way around occurs? So this happens. So immediately it gets boosted. And how did we use it in the logo? Basically, for all of the logos, we assigned exactly the same score. And then, depending on like who they competed with, we were adjusting their scores. And what we ended up with at the end is this distribution. So the distribution that we see here is actually the ELO score that was assigned was between -300 to 300. This is a range. And in between, we have how many logos actually fell into it. So we have the numbers. And then how can actually we create it into a label, and also quite simplistic one, but that will get us to the point of understanding what is beautiful or not. And the whole question, what is beautiful or not, it's really binary. So we said, okay, let's try to build a model that will say beautiful or not. And with using a bit of analysis, we came up with a threshold that separates the best the logos from beautiful to not beautiful. And you might say that it doesn't really work like that, that will be chopped, this is beautiful, this is not beautiful. So we did some adjustment in the algorithm to take the weight. Like the closer we are to threshold, the less confident we are. And this is something that we can pass to the machine learning algorithm to say that we sure here we are bad and we sure there we are good. So we are taking the angles much more seriously during the training. And when we look at the result, that's what we got from our training data, the one that we collected. And this is great. Like the beauty of this task is that it's so visually easily understandable. It's not like financial data, you look at the numbers. You can immediately understand if the model performs well or not. It's not performing, sorry, if the labeling was good or not. And okay, so we have now a bunch of logos, and we have the label. That's exactly what we needed for get the data. And then the next step was to do the data preparation. So how is each logo represented? So it's represented with a JSON. With a JSON that tells us about each component, each position, and some properties about it, and how can we actually translate it into something that is understandable by the machine. We spoke about it, it's numbers. And first of all, this is something that I explained. We got, so some of the things, most of the things actually, were generated manually. Onboarding information, it's, if you remember the video of Logo Maker, so we ask a bunch of questions to try to like fit what kind of fig do you want and some other things. So we are translating this information into a number. So for example, if you want to have modern feel, but there is like modern and fun and something else, modern would be 1, everything else will be zeros. And other things that I want to emphasize in this project, because I knew that I'm working with a design and I'm working with something that people do all the time, so I directed myself to different blogs that recommend you how exactly to build logos. So I read information and I came up with different kind of things that are easily translatable into numbers when I analyze the logos. So the symmetry, the alignment, the proportion, the aspect ratio. This is something that was recommended, and then I translated to help the model to understand what is beautiful. And we ended up with huge CSV file with a bunch of numbers. And we sent it to training. And the result was that in 86.2% of cases, we were correct. Okay, it might still seem quite low, but it's such a subjective task. You saw how much time it took us to ask humans to answer this question, and they failed. And there is this model that actually does it so successfully. We were very, very happy with it. We still actually are. And I don't want to get into the details, but here you see like how well we performed in terms of our errors. And another thing that, when I told you that it's a binary question that is between 0 and 1s, it's true, but there is the floating point between 0 and 1, right? The things that machine learning algorithm provides you, it doesn't provide you only yes or no, but it tells you how confident it is. So you have the confidence that starts from 0 and 1. The closer to 0 would be not beautiful, and the closer to 1 is beautiful. So what we actually extracted on the prediction, because you remember prediction, we actually run it over something that the model didn't see before. And for each of the logos, we could extract these images, and when you put it in the scale, like here it's very minimalistic example, but you can transition the beauty that becomes better and better and better to the end. And it was amazing. It was really amazing just to see it, how it works, and that it actually performs in the way that we humans would do, but it would take us so much more work to try to like shuffle them, what would be the positioning. And so we have this. This is amazing, but let's try to go to production to prove that the model actually works. Because everything was done, it was in the lab, it's never been interacted with any kind of customers, so how do we know it works? We decided to tackle this part. If you remember from the video, after you answer all the questions, the logo maker produces for you a list of designs that we suggest. So we said, let's try to go simple. Let's go to this page, and what we're going to do is that, I just forgot to say that, it's actually first impression of the product, so it's very, very crucial part because it gets a lot of traffic. And what we will do, we will just sort the logos that we provide for you by the beauty, by what algorithm considered to be beautiful and what is not. And then, so this is the production. We run an A/B test, so I would like you to guess which one is based on algorithm and which one is not.
Right one is algorithm?
Yes. So the right one was an algorithm. And the thing is that it's visually here I provided for you that it works, but how can we actually understand that it works correctly? So we had a bunch of KPIs that we can measure to understand the performance of the page. And what happened, and I'm not going to reveal you any numbers, it just, yes, it works. And we've proven it by improving the conversion on this page. The conversion rate of logos jumped. And it's something that we just reshuffle, resorted logos. We didn't do more than that. We didn't create anything new. But this was the point that proved for us the model works. The model works and the model is good. Because actually our customer said that it's good, but there are actions. But I just want to tell you that was a small POC to prove that it works. But now, since we have the model that knows the beauty, there are so many more things that we can do. And that's about the logo. And back to what I learned and what I would like to share with you. A lot of them been pointed before. But first of all, machines truly can learn anything, but we not always know how to teach them. So that's what I showed you in the project of like labeling. We didn't know how to provide this label, but as soon as we got there, it was amazing. Second of all, test your assumptions. We wasted so much time because we were overly confident, we knew all the answers. Spend a bit more time to try to like create multiple screens and work on with different people to understand what works or not. Just don't jump into things big, start small, multiple, and then it will direct you to the correct one. And the third one is I was so afraid of failures. I was really like, as any of us. And I faced so many failures during the project. I felt devastated, I felt useless, I felt I don't know anything. I felt like, what am I doing here in the company if I cannot tackle this small thing? But what it taught me, that it makes you more creative, it makes you grow. And now I'm so happy, like every time there is a failure, I know there is a new challenge that I want to tackle, that I feel very energetic and happy to face. So please fail, and don't be afraid of it. And I hope that next time you will be here speaking about your failures. So thank you.